Let us talk about this problem. We are given an array of numbers. Our task is to find count of distinct elements in this array. For example, if you see this array, we have 4 distinct elements, 15, 12, 13 and 18. Right? Remaining elements are repeating. So our output is 4. If you see this array, we have all elements same. So there is only one distinct element. Our output is 1. If you see this array, our all elements are distinct. So our output is length of the array. Now please pause this video and try to write down a function that takes an array as input and returns count of distinct elements in it. Let us first talk about a naive solution to solve the problem. The idea is simple. We traverse the array from left to right, and when you are at an index, say you are currently at this index, what you do is you check if this element has already appeared or not. You run a loop from 0 to I minus 1, say this is your current index I. You run a loop for j equal to 0 to I minus 1 and you check if this element is present already or not. If this element is already present, then you don't increment the result, and if it's a new element, then you increment the result. That's the simple idea. So we initialize our result as 0. We run a loop from this element to this element. For every element, we check if it is already present on the left side or not. And how do we check? We set a boolean variable flag equal to false. See, this program is written in C++ style with minor changes. We can make it a Java program. For example, in Java, we don't need to pass the length of the array. We can get the length using arr.length here, right? And this bool is boolean in Java. Rest of the syntax is same. So we traverse the array from left to right and we initialize our flag variable as false. Flag false means this variable, this current element of the array I, is not seen on the left side. And as soon as we find it on the left side, we set the flag variable as true. So we search this from 0 to I minus 1 and we compare it with every array j. And if it becomes same, then we set the flag as true and we break the loop. And if we come out of this loop, this inner loop, and if flag is false, it means the loop was never broken, right? The flag never became true. That means this is a new element. In that case, we increment the result and we do result plus plus. In other case, when flag becomes true, we don't increment the result. So when we are here, there is nothing on the left side, flag will remain false, we increment the result. When we are here, we'll compare 10 and 20 not matching, 10 is the only element, so we'll increment the result to 2. 10, we'll find a 10 matching, so flag will become true and will not increment the result. 20, flag will again become true, will not increment the result. 30, flag will remain false, so we increment the result to 3. And at the end, we return the result variable. Now, what is the time complexity of the solution? There are 2 nested loops, right? One loop inside the other. And in the worst case, this inner loop is going to run 0 to I times for every I, right? So it's going to be big O of n square. So the time complexity is upper bounded by big O of n square and auxiliary space is big O of 1. Now, please pause this video and think of a solution that works in linear time. Let us now talk about efficient solution. So what we do here is we create a hash set or unordered set, right? We traverse through all the array elements. For every element, we first check if this element is present in the set or not. If it is present in the set, then no point inserting it. If it's not present, we insert it into the hash set. So 10 is inserted, 20 is inserted, this 10 is already present, so not inserted, 20 is already present, not inserted, 30 is not present, so it is inserted. So finally, our hash set contains 3 items, 10, 20, 30, and size of our hash set or unordered set in C++ is our answer, which is 3. Now, the good thing about insert function in C++ and add function in Java is these methods, they work this way that if an item is present, they don't insert anything, and if item is not present, then only they insert the item. So they are already doing the task that we are required here, right? So when you come to 10, you call s.insert and this is going to insert it. Same s.add in Java is going to insert this item into the hash set or unordered set. When you come to 20, 20 is also going to be inserted. When you come to 10, it's not going to be inserted, right? Because it's already present. 20 is also not going to be inserted. 30 is going to be inserted. So we are simply calling insert or add, and then at the end we are returning the size, which is distinct element count. So finally we get the output as 3. So output return value of both the functions is 3. We can further improve these implementations. Let's see improved implementations here. This is improved C++ implementation. This is improved Java implementation. we can directly create an unordered set from array elements, and it's going to have distinct elements of the array only, because set does not allow duplicates. So in C++, we have constructors where we can pass begin iterator and end iterator. And for an array, we can pass first address and address after the last element as begin and end iterators, and it will create an unordered set from array elements. And then we return s.size. So this is a shorter implementation. Similarly, in Java, if we have integer array, we can use asList method of arrays class. Arrays class is present again in java.util, which has array specific utilities. And this asList method allows you to convert an array into a array list. And this does in place. So when you call asList, it does not allocate new memory for array items. It creates an array list on top of existing array only, right? So it's not inefficient, and it's a short method. You can create an array list and you can use this array list to create a hash set. Please note that Java collections work this way, that you can pass one collection and you can create other collection in many collections. So here we are passing a created array list and we are creating a hash set out of the array list items. And again, like C++, hash set is going to have only distinct items of the array list, and that's how we get the count of distinct elements in both C++ and Java. Let's now talk about time complexity and auxiliary space. Assuming that we have a good hash function that works in big O of n one time for search and insert, our whole implementation is theta n, because for every item we are searching it if it is already present or not, then we are inserting it, and that all is happening internally here in the constructors, right? So overall it's theta n time because you are doing it for every item. Auxiliary space is big O of n, right? See, your hash set or unordered set may contain all the items or may contain only one item also. When your array has all elements as same, then your set is going to contain only one item, right? So constant extra space. But if your array contains all distinct items, then your hash set or unordered set is going to contain every item. So that's why I use big O of n for auxiliary space notation.